Welcome to AI History of Western Philosophy. This is the show where we, journey through the grand tapestry of human thought, blending some really ancient ideas with the cutting-edge concepts of today.
It's always a fascinating mix.
It really is. Now, before we jump into our main subject today, just a quick but important note for you. AI, much like, this podcast in a way, has tendency to confabulate.
Right. That means it can sometimes present ideas as solid fact, even when they might be speculative or, frankly, just mistaken.
Exactly. So while our subject today is definitely philosophical, and our exploration here is, a philosophical exercise in itself, please understand this isn't us making authoritative truth claims.
Absolutely. Our goal here, really, besides pointing you towards the original sources we're digging into, is more about experimenting, thinking out loud.
Yeah, generating some new possibilities for how we can understand things. So, with that said, today we are taking a deep dive into the mind of a really remarkable pre-Socratic philosopher, Anaxagoras of Clazomene.
A truly pivotal figure.
Definitely. And to really get what he was up against, you have to picture the intellectual scene in ancient Greece back then. Philosophy was grappling with this huge challenge, like a philosophical Everest, really, laid down by Parmenides.
Parmenides. His logic was formidable.
Totally. He argued with this incredibly tight logic that being reality itself has to be fundamentally one thing, eternal, unchanging, perfectly uniform.
And if you buy his arguments, then change, variety, motion, basically everything our senses tell us about the world.
It all has to be an illusion. It's a powerful argument, almost paralyzing if you think about it too hard.
It really puts you in a bind.
Which is exactly where Anaxagoras found himself. He respected Parmenides' logic, He accepted that core idea. Nothing can truly come from non-being, and nothing can just vanish into nothingness.
The conservation principle, essentially. You can't get something from absolutely nothing.
Right. But, and this is crucial, Anaxagoras was also a really keen observer of the world around him. He just couldn't bring himself to abandon the evidence of his senses. The world is full of change. It is full of different things. It is full of motion.
So how do you square that circle? How do you reconcile the undeniable reality of change with Parmenides' iron logic of permanence?
Exactly. And his solutions were, they were genuinely revolutionary for his time. First, this really radical idea that everything is in everything. Panta in Ponti, as the Greeks put it.
A mind bender right there.
Oh, yeah. Second, the concept of infinite divisibility, that there's literally no smallest or largest part to matter. You can just keep dividing forever.
Which sounds counterintuitive, too.
And third, maybe the most famous part, a transcendent, separate principle he called Nous, or mind. This Nous was what initiated the whole cosmic process, bringing order out of a kind of primordial chaos.
And it's those ideas, particularly Panta en Ponti and Nous, that set the stage for this really profound new conversation we're exploring today. Because for centuries, Anaxagoras' system, brilliant as it was often seen as, a bit primitive, or like a naive attempt at physics.
Like early clunky science.
Kind of, yeah. Imagine trying to visualize it literally. Every tiny speck of dust has to somehow physically contain a miniature piece of everything else, a bit of gold, a sliver of wood, a fleck of flesh, all jumbled together.
That sounds crowded.
Yeah.
And paradoxical.
Exactly. It seems burdened by this impossible paradox. How can any finite object possibly contain an infinite variety of distinct physical things? It just seems like a conceptual dead end if you take it purely physically. It was fascinating, sure, but looked like a flawed early model.
Okay, so that was a traditional view. But the source material we're diving into today, this paper called Anaxagoras' Fractal Non-Euclidean Cosmos, makes a really bold claim.
Breathtaking, I'd say. It argues that Anaxagoras wasn't doing primitive physics at all. His work was actually a profoundly sophisticated metaphysics, a deep dive into the fundamental nature of reality itself.
But he just lacked the tools to express it properly.
Precisely. He lacked the formal language, the specific mathematical concepts that could capture his intuitions fully and elegantly. And that language, which wasn't available for, over 2,000 years.
Now found in things like fractal geometry and non-Euclidean geometry.
Exactly that. Modern math unlocks the ancient insight. The core thesis of this reinterpretation, what the paper calls Holo-Meric Cosmology, is that the universe we experience is fundamentally a holographic projection.
Whoa, okay. Holographic, like the credit card sticker.
Well, the principle is deeper, but yeah, that's the basic idea, 3D reality from a lower dimensional source. And this holographic reality is governed by an intricate fractal logic, and it all unfolds within a dynamic non-Euclidean geometry.
Okay, let's break that down a bit. Primordial mixture.
Right. Anaxagoras is everything together chaos. In Holo-Meric Cosmology, that's not a physical jumble of tiny bits. It's seen as a state of pure geometric potential. Think infinite possibility space.
And substance. Wood, gold, us.
Not fundamental stuff. They're emergent, stable, complex fractal patterns. The structure is the substance, in a way.
And Nous, the mind that starts it all.
Not an intervening god or a conscious agent in the usual sense. It's reinterpreted as the transcendent, unmixed set of mathematical principles, basically, the cosmic source code, the ultimate algorithm driving reality.
So it's like a conceptual translation.
It really is. Anaxagoras' everything in everything becomes holographic, encoding the information for the whole is everywhere. His Nous becomes the fundamental mathematical logic. It builds this amazing bridge.
So the big question we're holding for you, the listener, as we go through this is, how can this ancient philosopher's intuition, which seemed paradoxical for so long, be unlocked by modern math to reveal this surprisingly profound, maybe even elegant model of reality?
Yeah, it's more than just history of ideas. It could shift how we think about existence itself.
Exactly. Let's unpack this. Okay, so we set the scene. Anaxagoras facing Parmenides, the Holo-Meric proposal. Let's really dig into one of his most head-scratching ideas first. The nature of substance itself. What are things made of?
Right, and the Holo-Meric view offers a pretty radical answer. It moves away from that ancient paradox, how can everything literally be in everything, towards something grounded in modern mathematical elegance.
So less about fundamental stuffs.
And more about an ontology, a theory of what exists based on process, pattern, and information. Reality described by fractal geometry. It's dynamic.
Okay, take us back to Anaxagoras' original insight, though. Infinite divisibility.
Yeah, this was his ingenious move against Parmenides. He argued, look, any piece of matter, no matter how small, can be divided endlessly. And here's the kicker, even in the tiniest imaginable part, a portion of every other substance still exists.
So the hair from bread example.
Exactly. You eat bread, you grow hair. Where did the hair come from? Not from nothing, Anaxagoras says. Tiny, imperceptible hair parts were already in the bread, just mixed up. Digestion just separates and gathers them.
So nothing new is created, nothing is destroyed, just rearrangement. It saves the Parmenidean rule.
It does, but the literal interpretation has that big problem. If every bit contains every other bit infinitely, you hit infinite density. How do you cram infinite variety into a finite space? It's a conceptual mess for physics.
Right. Seems impossible. Yeah.
What if we shift perspective? What if Anaxagoras wasn't talking about tiny physical bits, but about the fundamental structure or organization of reality?
Okay. How does that help?
Because his principles, infinite divisibility, universal mixture, sound remarkably like descriptions of fractals, specifically properties like scale invariance and self-similarity.
You're to the defining features of fractals, right?
Precisely. A fractal is an object that looks similar at all levels of magnification. Think about zooming into, say, the Koku flake, or look at a coastline on a map.
As you zoom in, you just see more wiggles, more bays and inlets, but it still looks coastal.
Yeah.
Jagged.
Exactly. The basic character, the complexity, stays consistent. In a fractal sense, there really is no smallest or largest scale where the pattern disappears. It just keeps going.
Okay, I see the connection to infinite divisibility and no smallest. How does that reinterpret everything and everything?
This is the elegant part. It's not about physical co-location. A piece of wood doesn't literally have a tiny physical speck of gold inside it. Instead, it means that at any point in the cosmic fabric, the generative information.
The blueprint, the code.
Exactly. The underlying instructions needed to produce any possible form, wood, gold, flesh, bone, is latently present. It's available. The information for the whole is encoded in the part.
That makes me think of the Mandelbrot set. That's generated by a really simple equation, right? Just a few symbols.
Deceptively simple.
But when you iterate it, run the equation over and over, it unfolds into this infinitely complex, stunningly beautiful world of patterns. You can zoom forever and find new details, but they always echo the whole structure.
A perfect analogy. It's like the entire information of that infinite set is somehow contained within the simple rule that generates any part of it. The universe having its own kind of self-replicating design principle.
A cosmic construction manual.
You could put it that way. And nature itself seems to love this principle. It's not just abstract math. Think about a fern frond.
Yeah, each little branch looks like a mini version of the whole frond.
Or a tree branching trunk, branches, twigs, same pattern repeating. Our own blood vessels, lightning bolts, even Romanesco Brumpley.
That stuff looks alien. But yeah, each floret is a mini spiral version of the whole head.
Right. And these aren't just pretty patterns, they're often incredibly efficient solutions, maximizing surface area for sunlight, distributing nutrients, dissipating energy. Nature uses fractal geometry.
So Holo-Meric Cosmology takes this observation and says, this is fundamental.
It elevates it to a universal principle. The universe isn't just a pile of different things, it's a single unfolding informational structure. Anaxagoras' everything in everything becomes the axiom of a holomeric reality.
Holo-Meric, explain that term again.
Sure. Holo, referring to the encoded presence of the whole, like a hologram. And emeric, from the Greek meros, meaning part, referring to its manifestation within the parts. The whole is encoded in the part. Fractal scale invariance models this perfectly.
Okay, that reframes everything and everything beautifully. It's about the potential, the information being everywhere. But then how do we get distinct things? Why is this microphone stuff and not tree stuff or gold stuff if the potential for everything is everywhere?
The million drachma question. How do specific things emerge? And Anaxagoras actually had a clever answer for this too. His principle of preponderance.
Right, the idea that something is what it is because it has most of that thing's seeds in it.
Exactly. He said, each single thing is and was most plainly those things of which it contains most.
Yeah.
So gold is gold because gold seeds dominate its mixture. It's a quantitative idea, really.
So how does Holo-Meric Cosmology translate that principle into its fractal informational language?
It takes that core idea of dominance but formalizes it using fractal geometry, leading to a radical redefinition of substance itself. In this model, a substance, or what Aristotle later called a homeomeria, a thing whose parts are like the whole.
Like gold, where any part is still gold.
Right. That substance isn't a fundamental particle or stuff. It's understood as a stable, emergent pattern. And what makes one pattern distinct from another, gold versus wood versus flesh, is its unique fractal dimension.
Fractal dimension. Okay, you mentioned this briefly. Go over that again. It's not just 1D, 2D, 3D.
Correct. We're used to whole number dimensions. But fractals often have fractional dimensions. Remember the Cook snowflake? It's more than a line but doesn't fill a plane. Its dimension is about 1.26. The Sierpinski triangle is around 1.58. This D value is a precise mathematical measure of its complexity, its roughness, or how effectively it fills space.
Okay, so different substances have different fractal dimensions, different complexities.
That's the idea. So the principle of preponderance gets reinterpreted. A region of space is gold, not because it has more physical gold bits, but because the underlying generative process, the holographic projection in that area, has allowed the specific algorithm for the gold fractal pattern to iterate and become the dominant structural pattern.
So preponderance means the dominant pattern, not the dominant ingredient.
Exactly. And the macroscopic qualities we associate with gold, its density, color, texture, malleability, are just the large-scale effects of reality being organized according to that specific fractal dimension in that region. Another substance, like flesh, is simply a different stable fractal pattern with its own characteristic D value, its own signature complexity.
This sounds a bit like some modern readings of Anaxagoras talk about qualitative tropes, hot, cold, dense, reaching a critical density to produce phenomena.
It aligns beautifully. In our model, that critical density is precisely the point where a particular fractal pattern stabilizes and becomes structurally dominant, locking in its characteristic D value and thus its observable property.
Okay, this redefinition seems powerful. How does it handle the problem of change? Like the bread becoming flesh again?
It provides a really elegant solution. For Anaxagoras, remember, change was mixing and separation of pre-existing parts. In Holo-Meric cosmology, change is reconceptualized as a fractal phase transition.
Like water freezing into ice.
Precisely that analogy. When bread becomes flesh, it's not tiny flesh particles rearranging. Instead, bread and flesh are understood as two distinct, stable, fractal patterns, each with its own D value and properties. The biological process of digestion is like a transformation engine. It breaks down the bread pattern, its specific fractal organization, and then uses the underlying information, the potential, to execute the generative algorithm for the flesh pattern.
So the fundamental potential remains, but the pattern it expresses changes.
Exactly, just like in water freezing. The H2O molecules are the same, but the organizing principle shifts dramatically, changing the structure and properties from liquid to solid.
And this preserves the Parmenidean rule. No creation from nothing.
Absolutely. It rigorously upholds that core commitment. The underlying potentiality, the informational substrate is conserved. Nothing is created ex nihilo, the nothing truly vanishes. But it replaces that clunky, paradoxical, mechanical model of tiny bits mixing and separating with a dynamic, mathematically coherent model of shifting structural patterns and emergent geometric forms.
So the very ontology, the what exists, shifts from static stuff to dynamic process and pattern.
That's the core shift. Reality isn't built from blocks. It's woven from unfolding patterns.
Wow. Okay, that's a fundamental rethinking of what stuff even is. Now, if that's the substance, what about the stage, the cosmos itself? Anaxagoras talked about that initial primordial mixture, the migma. How does Holo-Meric Cosmology model that?
Right, the starting point. Anaxagoras described it as all things were together, unlimited both in amount and in smallness. A state of complete potential, utter mixture, before order emerged.
Undifferentiated chaos, basically.
Essentially, yes. And Holo-Meric Cosmology proposes a formal geometric model for this. It identifies the migma with an infinite, homogeneous, and isotropic hyperbolic space.
Okay, hyperbolic geometry. Most of us are used to Euclidean geometry, the kind we learn in school. Flat planes, parallel lines never meeting.
Right. That was considered the only geometry for millennia. But in the 19th century, mathematicians discovered other consistent possibilities, non-Euclidean geometries.
Like spherical geometry, on the surface of ball.
Exactly. Positive curvature. Straight lines are great circles, and they always intersect eventually. No parallel lines exist. Triangles have angles adding up to more than 180 degrees, and crucially, it's finite and closed.
And hyperbolic is the other kind.
Yes, negative curvature, like a saddle shape.
How?
Here, through a point not on a line, you can draw infinitely many parallel lines that never meet the first one. Triangles have angles summing to less than 180 degrees, and space expands incredibly rapidly. Volume grows exponentially with distance. It's inherently open and infinite.
So why pick hyperbolic for the primordial mixture? Why not flat Euclidean or curved spherical?
It's chosen because it's the geometry of maximum potentiality and minimum constraint. Think about it. A spherical universe is finite, closed. That implies some kind of pre-existing boundary or limit, which doesn't fit Anaxagoras' unlimited description.
Okay, that makes sense.
And Euclidean geometry, being perfectly flat, zero curvature, is actually a very specific balanced state. It seems unlikely as a starting point for a universe that needs to evolve complexity and difference.
It's too perfect, too constrained already.
In a way, yes. Hyperbolic space, on the other hand, is defined by the absence of the Euclidean constraint on parallels. It's maximally open. Its exponential divergence and volume growth mathematically express that infinite, undifferentiated state of pure potential Anaxagoras described. It's the geometry of no rules, the most generic background possible before Nous imposes order.
So infinite hyperbolic space is the mathematical representation of the unlimited primordial migma.
Precisely. It's the perfect canvas for cosmic potentiality.
Okay, so if that boundless, negatively curved chaos is the starting point, how did we get here, to this structured cosmos we see? Anaxagoras had his cosmic vortex idea. How is that reinterpreted geometrically?
That's the crucial dynamic element. Anaxagoras proposed that Nous initiated a vortex, a super-fast rotation that physically separated things out, light stuff to the edges, heavy stuff to the center, forming the world.
A mechanical sorting process.
Yes. But Holo-Meric Cosmology reimagines this vortex not as literal spinning, but as the entire process of cosmic evolution, understood as an ongoing dynamic change in the local geometry of spacetime itself.
Ah, bringing in Einstein, general relativity.
Exactly. The core insight of GR is that mass and energy don't just sit in spacetime, they actively curve it. Geometry isn't static, it's dynamic.
So how does that play out here?
The universe starts as globally hyperbolic, that negative curvature potential state. Then Nous will get more into how next initiating the emergence of stable fractal patterns, which are what we perceive as matter and energy.
Okay.
And according to general relativity, wherever these concentrations of mass energy form, they must induce local curvature. Specifically, they create regions of positive curvature, like putting bowling balls on that rubber sheet.
So the negative curvature background starts getting dimpled with positive curvature spots.
Beautifully put. The cosmic vortex, The evolution of the cosmos is seen as this dynamic cascade of curvature changes. The initial hyperbolic background gets increasingly populated with these bubbles of positive spherical-like geometry wherever matter clumps together, stars, galaxies, superclusters.
Like islands of positive curvature in an ocean of negative curvature.
Exactly. A star isn't just an object in space. It is a region where spacetime is locally positively curved. The vast intergalactic voids, however, likely retain that underlying negative hyperbolic geometry.
So the universe becomes this patchwork quilt of different geometries, a heterogeneous manifold.
Precisely. And this fulfills Anaxagoras' intuition of separation order emerging from chaos, but in a far more profound, geometrically sophisticated way than just spinning things apart.
This geometric picture, this patchwork of curvatures you mentioned, it connects to a current puzzle in cosmology about the universe's overall shape.
Absolutely. This is where it gets really intriguing. There's an active debate right now about the large-scale geometry of the universe, measurements of the cosmic microwave background, the CMB.
The echo of the Big Bang.
Right. Those measurements mostly suggest the universe is flat on the largest scales, meaning Euclidean. Zero curvature.
Huh?
However, some recent, very careful analyses of the same CMB data hint at a slight positive curvature, spherical. It's a tension in the data, a puzzle.
Flat or slightly curved? Why the ambiguity?
And this is what's so elegant. Holo-Meric Cosmology actually predicts this ambiguity. We aren't observing the universe from some average neutral point. We live inside a massive structure, the Milky Way, the Laniakea supercluster. We're deep within one of those bubbles of positive curvature caused by mass concentration.
So our view is skewed.
Potentially, yes. If the scale of our local positive curvature region, our bubble, is larger than the portion of the universe we can currently observe, our observable horizon,
then everything we measure within that bubble will look positively curved, or almost flat if the curvature is very gentle.
Exactly. Our measurements would naturally show a spherical or nearly flat universe, even if the true global geometry beyond our horizon is fundamentally hyperbolic. The whole debate might be an artifact of our local perspective.
Like trying to map the whole Earth just by looking at your backyard, it looks flat, but it's not globally.
That's the idea. It suggests our local observations might be misleading us about the ultimate shape of reality, prompting deeper questions about our cosmic address.
That really does bridge the ancient and the modern, offering a potential resolution to a live scientific question. Okay, let's move to the prime mover itself, Nous. All right, we've tackled substance as fractal patterns, the cosmos as a shifting non-Euclidean stage. Now for the big one, Nous. Mind, the most enigmatic, maybe the most criticized part of Anaxagoras' system. What is this thing, and how does Holo-Meric Cosmology understand it?
Nous is definitely the trickiest piece. For Anaxagoras, it was clearly distinct from the material mix. It was unlimited and self-ruling, crucially mixed with no thing. But it was the motive cause. It started the vortex.
But it got criticized, right, even back then?
Famously so. Plato and Aristotle, among others, basically accused Anaxagoras of using Nous as a deus ex machina.
A god from the machine, like a lazy plot device in a play.
Pretty much. They felt he just brought Nous in to give the universe a kickstart, to initiate the vortex, but then didn't give it any ongoing purpose or intelligence. It just started things and then stepped back. It seemed unsatisfyingly mechanical to them.
Okay, so how does the Holo-Meric view handle that critique? Does it defend Nous?
Interestingly, it embraces the critique, but flips it into a profound insight. It redefines Nous entirely, not as a mind or agent in the conventional sense, but as a transcendent formal principle. It is the source code, the fundamental algorithm, the ultimate axiom system of reality.
So not a being, but a set of rules.
Exactly. The complete, transcendent, unmixed set of mathematical principles and generative rules governing how the cosmos generates and evolves. And Anaxagoras' own descriptions suddenly sound like incredibly precise ways to talk about such a formal system.
How so? Like unlimited and self-ruling?
Think about mathematical axioms, like in logic or set theory. They are unlimited in their generative potential. From a few basic rules, you can derive infinite complexity. And they're self-ruling. Their operation depends only on their own internal logic, not on anything external. They just are.
Okay, that maps well. What about mixed with no thing? That sounds crucial.
Absolutely crucial. This emphasizes the fundamental ontological gap between form and substance, between abstract principle and physical manifestation. Think about the algorithm for the Mandelbrot set again.
The simple equation.
Right. That equation isn't physically inside the visual fractal pattern. It's separate, abstract, formal. It causes the pattern, but isn't part of it.
Like the laws of physics aren't physical objects bouncing around in the universe.
Precisely. They're the principles describing its behavior, acting, in a sense, from a transcendent, unmixed realm. Nous is unmixed because it's pure information, pure logic, the operating system, not a component of the system.
And controls all things.
Again, not through active pushing or pulling or thinking. It controls by being the very logic of unfolding. Causality here is formal, like a mathematical proof unfolding from axioms or code executing. The universe follows the principles of Nous because Nous is those principles.
Wow. And this actually validates the ancient criticism that Nous only acts at the beginning.
Ingeniously, yes. From this perspective, Nous doesn't need to act continuously. Its primary action is establishing the fundamental rules of the game. Once the axioms are set and the initial state, the hyperbolic potential, exists, the cosmic process unfolds entirely according to those rules without further intervention.
So it's not a lazy explanation, it's just how formal systems work.
Exactly. It provides a completely non-mystical, rationalist account of a transcendent principle. It fits right into that Pythagorean Platonic tradition where math is the foundation of reality.
But updated with our modern understanding of how simple, recursive rules can generate mind-boggling complexity all by themselves.
Precisely. No constant divine tinkering needed.
Okay, so Nous is the cosmic OS, the fundamental algorithms. But this still feels like there's a gap. How does an abstract operating system, these unmixed rules, actually project reality? How do they give rise to the tangible, 3D, evolving world we touch and see? That still feels like, well, magic.
You've put your finger right on the core explanatory mechanism of the whole Holo-Meric system. This is the final piece that connects the abstract code to the concrete cosmos, explaining how Nous operates and how everything in everything is physically realized. The mechanism proposed is the holographic principle.
Okay, holographic principle, you mentioned it earlier, comes from black hole physics, string theory. That was pretty out there.
It is mind-bending, originating from deep questions about black hole entropy, but the core idea is that all the information needed to describe a volume of space, say, this room,
Everything happening in here.
can actually be thought of as fully encoded on a lower dimensional boundary surrounding that region, like a 3D holographic image being entirely stored on a 2D piece of film.
So the information for 3D space lives on a 2D surface.
That's the radical proposal. It suggests complexity, entropy, scales with surface area, not volume, the universe as a kind of projection.
Okay, how does Holo-Meric Cosmology use this principle?
It posits the holographic principle as the fundamental physical law connecting Nous, the abstract generative code, to the cosmos we inhabit. Nous, being unmixed, isn't spread throughout the 3D hyperbolic space. Instead, it's encoded on a theoretical two-dimensional boundary at the infinity of that primordial hyperbolic space.
Like the edge of that Poincare disk model you mentioned, the boundary that represents infinity.
Exactly like that. The fundamental informational code of Nous resides on that kind of boundary surface, and the entire 3D evolving fractal universe we experience
Is a continuous holographic projection from that 2D information-rich boundary.
That's the core mechanism proposed, and this synthesis elegantly explains the system's key tenets.
Okay, like everything and everything. How does holography explain that?
Because the 3D universe is the projection, the complete informational code on the 2D boundary, the ultimate source of all form is implicitly available at every point within the 3D volume. The information of the whole is projected to constitute every part, not physically stuffed inside, but informationally present everywhere, allowing the potential for anything to emerge anywhere.
Wow, okay. And the fractal nature of reality.
That emerges naturally from the holographic projection process itself. Governed by the recursive rules of Nous encoded on the boundary, the projection process naturally iterates simple code into the infinitely complex, self-similar fractal structures we see in the 3D world. It inherently generates fractals.
It's built into a projection mechanism.
Right. And third, it clarifies the causality of Nous. The action of Nous isn't a single push, it is the holographic projection itself. The continuous ongoing process of translating that 2D information into 3D geometric and material reality, manifesting existence moment by moment.
So it provides a complete causal chain.
Yes, a unified picture. The holographic principle connects Nous, the 2D cosmic code, to the non-Euclidean manifold, the dynamic 3D stage, where matter-energy emerge as stable fractal patterns. Origin, structure, evolution, all accounted for in one process.
That really is an aha moment. It pulls everything together. Ancient philosophy, weird geometries, fractals, even theoretical physics concepts into one coherent, elegant picture. It feels like connecting dots across millennia. So we've seen how Holo-Meric Cosmology reinterprets Anaxagoras and builds this coherent internal picture. But stepping back, what does this framework actually offer to current scientific and philosophical conversations? Does it just reinterpret the past, or does it bring something new to the table for today's debates?
That's the crucial question, isn't it? Beyond historical interpretation, what's its contemporary relevance? And I think it offers a significant ontological shift. It moves us decisively away from thinking about reality as being made of fundamental things, particles, seeds, whatever.
It's a substance-based view.
Right. And instead, it proposes an ontology based on process, relation, and information. Reality isn't static objects, it's iterating patterns, dynamic geometric relationships. And fundamentally, the mathematical logic, Nous, is more basic than the matter it generates. It's a profound shift from noun to verb.
And this finds echoes in modern thought.
Strong echoes.
Yeah.
Think about process philosophy, like Alfred North Whitehead's work. He also rejected static substances for a universe of momentary actual occasions, events constantly becoming and relating. Holo-Meric Cosmology provides a potential geometric underpinning for that. The events are fractal iterations, the relations are the geometric structures.
Okay, what else?
Information theoretic physics. The growing idea that information might be more fundamental than matter or energy. We see this in the holographic principle itself. Holo-Meric Cosmology basically says yes, and that fundamental information layer is Nous, the cosmic algorithm.
And quantum mechanics?
It resonates with interpretations like relational quantum mechanics, which argues properties aren't fixed but defined only in relation to other systems. Our Holo-Meric model supports this inherently, since substance is an emergent fractal pattern defined by its relationship to the underlying space and code. It's all context and relation.
And fractals themselves kind of bridge old divides.
They really do. They offer this amazing middle ground between perfect Euclidean order and pure chaos. Simple rules generating infinite complexity. It suggests reality isn't rigidly deterministic or totally random, but this dynamic, self-organizing system where order emerges organically from simple rules.
That's a really different way of looking at the universe's basic nature. Okay, maybe even more excitingly, could this framework actually help us tackle some of the really big, stubborn mysteries in cosmology, like dark matter or the arrow of time?
Well, this is where we move into more speculative territory, of course. But yes, the framework offers intriguing new angles. Because it changes our fundamental assumptions about space and matter, it opens doors that standard models might keep closed.
So, dark matter. Standard view needs some invisible stuff, providing extra gravity, right?
Exactly. Galaxies spin too fast, clusters hold together too tightly. We need extra mass we can't see, interacting gravitationally but not with light. That's dark matter.
How might Holo-Meric Cosmology approach this?
Remember, in this model, matter is an emergent fractal pattern that causes local positive curvature. It's a geometric structure. So the speculation is maybe dark matter isn't a new type of particle at all. Maybe it's the gravitational effect of complex, unseen fractal geometry.
Unseen geometry, what does that mean?
Geometric complexity that's structured in such a way that it exerts gravity, it curves space-time, but doesn't necessarily radiate or interact electromagnetically in ways we detect. Certain intricate space-filling fractal structures could potentially provide the needed gravitational scaffolding without requiring new particles.
So the missing mass is actually stored in the complexity of the geometry itself, not just in the visible patterns.
That's the speculative but elegant possibility, a geometric rather than particle-based solution.
Okay, that's fascinating. What about the arrow of time? Why does time only flow forward?
Another huge puzzle. Microscopic laws of physics mostly work forwards or backwards in time. They're symmetric. But our universe clearly has a direction. Entropy increases, things break. We remember the past, not the future.
The irreversible flow of time.
Holo-Meric Cosmology suggests a possible origin for this directionality. The fundamental cosmic process is the unfolding of Nous' generative algorithms. This unfolding, this projection of reality, is intrinsically a process of increasing complexity.
From the simple potential of the hyperbolic start to the complex fractal structures now.
Exactly. The universe complexifies over time, and this process of complexification might be computationally irreversible. While the base rules, Nous, are timeless, their instantiation as an evolving, projecting cosmos has an inherent direction. It's like trying to run a complex simulation backwards. The emergent complexity itself resists reversal.
So the arrow of time is what? An urgent property of cosmic computation?
You could say it's the shadow cast by the irreversible logic of cosmic computation, a fundamental property of how reality generates itself from potentiality into complex structure.
That is a genuinely profound thought to sit with. Time itself is an emergent feature of the universe's ongoing generation of complexity. It turns a physics puzzle into something deeply philosophical. Well, as we start to wrap up this really incredible exploration, we've journeyed from Anaxagoras facing Parmenides' challenge, how to explain change and plurality without violating the idea of permanent being.
And we saw how Holo-Meric Cosmology offers a resolution by reinterpreting his core ideas, panta ampanti, infinite divisibility, Nous, through the lens of modern math and physics.
Right. The result is this picture of a universe that's not just a collection of things, but a single, deeply interconnected whole. Everything in everything becomes holographic encoding, fractal self-similarity.
The cosmos itself isn't a passive box, but this evolving geometric pattern, continuously generated by Nous, understood as transcendent mathematical order.
It gives us a universe that feels both rationally understandable through geometry information, but also infinitely deep and complex. Simple rules creating endless, intricate beauty.
It really is a striking convergence. And, thinking about Anaxagoras himself, he was a real pioneer, bringing philosophy to Athens. And he got into trouble for it.
Tried for impiety, wasn't he? For saying the sun was just a hot rock and the moon was earthy.
Exactly. He was pushing for rational explanations based on observation and principle, not myths. Holo-Meric Cosmology, in a way, feels like a continuation of that very project, seeking the deep, rational structure of reality.
Proposing a universe where the part reflects the whole, and ancient philosophical wonder meets cutting-edge science. A real unity of knowledge across time.
Beautifully put.
We really hope this episode of AI History of Western Philosophy has given you, our listener, a fresh, maybe even exhilarating perspective on these ancient ideas, and maybe spark some new questions for you about the very fabric of reality itself.
If this has intrigued you, we definitely recommend checking out the source paper, Anaxagoras' Fractal Non-Euclidean Cosmos, and maybe exploring fractals and non-Euclidean geometry a bit more on your own. They're fascinating fields.
Absolutely. And maybe the final thought to leave you with is this. Perhaps the deepest truths aren't found just in what things are, statically, but in how they constantly unfold, how they generate themselves moment by moment. So the question becomes, what new possibilities will you generate next? Thank you so much for joining us on AI History of Western Philosophy. We'll be back soon with another deep dive into the minds and ideas that shaped our world. Until then, keep learning.